Hi everybody, we're going to do a tutorial on programming in processing, specifically about control structures in processing. During this tutorial, what I want you to do is I want you to start processing and program along with me. Before we get started, from going into the labs and talking to you guys, I've noticed a lot of people are programming in very small font, which can't be good for your eyes. So if you don't know this already, you can go to File, Preferences, and set the font size for your editor, and as well as your console, which is down here. So I have set mine. I have a Surface. Text is generally small on it, so I've set it to 30. So you set it to whatever that works for you, but make sure that it's big enough that it doesn't bother your eyes. So if you have a program such as this in processing, first of all, I want to talk about the window in processing. And I've talked about this a little bit in the past. So it's an 800 by 800. Again, it doesn't look that huge because I am programming on a Surface. So it's a different graphics card. On this window, the size is set by us. So I've set my size to 800 to 800. That means X at 0 is over here and X 800 is over here. So over here, X equals 800. The same as Y. So Y 0 is up here and the depth increases as you go down. So Y 800 is actually down here. In order to make things easy, processing actually saves the size you give it in two different variables. It saves the width in a variable called width, and it saves the height in a variable called height. So let's tell you what I mean. So these are variables that you have not set yourself. It's just that processing sets them and stores the size of the screen. So for example, if I say println width, and you right away you see that it's a keyword, the color changes. That's how you know it's a keyword. So the width of the screen is going to be 800. Height is another keyword which is reserved for Y. So if I run this now, you see 800, 800, that's width and height. So interesting to see. If we didn't have this, so if I comment this line out, so the size is no longer set anymore. Let's see what is the size of the window. The default size is 100 by 100, which looks tiny on my computer anyways, right? So it's 100 by 100 by default. If I uncomment this, which means it's going to be executed again, it is going to be 800 by 800. Okay, so I don't need this anymore. I'm gonna delete this. So we run this program in Draw. I'm drawing an ellipse. So every time this program is running right now, it redraws the background and it draws a circle. It's an ellipse, but because the dimensions are equal, it's going to be a circle. So this is happening over and over and over and over again. This is because of the draw function. It's a perpetual loop. By the way, one of the things that sets the processing language apart from other languages is the draw function. So the draw function is a very unusual function. Not other functions aren't like this, but this is part of processing that we have to learn, and this is what makes animation possible. So it is actually a pretty cool and interesting function. So if you want to get it moving right now, you see that I have everything as constant, so 200, 280, and 80. So we need to add some variables in there, and this is so we can have 8 int x, and we can originally set it to 10. Y, we can set that originally to 200, and y to 200. So if I change this to x and that to y, and I can say x, and let's say +3, and y +3. So if you run it now, you kind of see it move in that direction. I want to just look at the x, because you're increasing the x and y together. I want to just look at the x direction though in this video. So let's look at the x direction only, and right now if I run this, you kind of see this going in the x direction. It goes out the window. We said that if we want to stop it from not going out of the window, we could just simply say if x is less than 800, or I can just say width, then add, and I said it should be x plus 40. So it's going to stop here. First of all, it is preferred you guys write width here and you don't write the number. The reason is if I write width here, and if I decide to change the size of my screen, I don't have to go and change 800 all throughout my program. So I can just use width, and I can basically change this size once on top, and it's going to take effect for the rest of my program. It is not going to be the case if I write 800 here. In that, if I write 800 here, or if I have 800 a few other places, basically what happens is, if I want to change the size of my screen, I have to go throughout my program and keep deleting 800 and set it to the new size. So using this variable width is quite advanced. It's advantageous. So with regards to x plus 40, I think that should be clear to everybody why we do this. And this changes for different things, but as we explained before, if you have your circle, no, that's a pretty bad circle, sorry. Let me try to. If you have your circle like that, this is no better, but so x is actually here, right? So the diameter of the circle is this, which we set it to 80. Half of that, which is the radius, is 40. So x is here. This is different from a rectangle. So if you have a rectangle drawn, the x and y are actually both measured. They're not at the center, but for the sphere, for an ellipse or circle, the x and y are actually at the very, very center of it. So you have to keep that in mind when you do these problems. Anyways, so we have this code right now, and if we run, it goes and it stops there. So now I want to do a problem with you in that it gets our circle to come here and then go back, and basically goes back and forth on the screen, goes in the horizontal direction. So how do we do that? Maybe pause the video. So if you already got that, I basically want the ball to go to the very, very far right, and then bounce back and go to the very, very right, to the very, very left hand side, all in the horizontal level, so there is no deviation in the vertical. So maybe pause the video and think about this for a second and see if you could do it, and then come back and we'll solve it together. Okay, so thinking about this problem, it really boils down to direction. So here, by saying x equals x plus 3, we are basically saying to move in the positive direction, or basically move to the right, and it stops there. What we want is to say go maximum to the very, very right, and then start moving to the left, go to the maximum left, then start moving to the right again. So it's all about direction. So what we would do is, first of all, we don't want it to stop at that point anymore. So first, what we need is a variable that would be about direction. So we would have int, let's say this is x direction, so we'll say x there as in x direction, and we'll set it to 1 to begin with. And basically we need to say if the ball was ever on the right side, or if it was at the left side, change direction. So we would say so let's get rid of this. So this is when the ball is at the right side. So if ball is at the right side, or if x, this is minus 40 now, right? X minus 40 is less than or equal to 0, and you want x plus 40 to be, if it was greater than or equal to 40 to the width, then you want to change direction. So you simply want to say x star minus 1 to change direction like that. And then of course here we can say x plus minus x star. And the direction we could basically change it to, let's change it to 3, so it moves faster. So let's see how this works. So it goes to the very top, then it changes direction, it's coming back, then it goes back, and see it just does this over and over again until you're done. So let me move this so you can see the code. So two cases: if it's equal or getting larger than width, or it's getting less than 0. So in fact, you could even get away with taking the equal signs out. It depends on your x there. So like if let's see what happens when I take the equal signs out. So it goes. It's really fast. You can't see it, but basically there is a danger of going in a little bit because the limits aren't set as hard as they are. So, but anyways, this is how it would work. You can debug your program. If your program isn't doing what you think it should be doing, you can debug it. How do you debug it? You place in print statements. So for example, you want to know what's happening to the x direction. Let's say you can basically have a print ln, and you can get it to output x direction as well as maybe outputting x, just to see what's happening to those two numbers. So when I run this, as it's running, you can kind of see. So now it changed. That's -3, so it comes back. Then 3 and 38, and go back and forth. So you can come every time it hits there. That's the value. That's the value that you get. So you can kind of see at what values this is bouncing back. So this is going to be quite important. All right. Well, enjoy programming. Thank you.